Okay, in this problem, we want to compare two different groups, man and woman, based on how much or how many text messages they send every day. We did something similar on module number 11 when we compare two groups with t-test and find out if there are difference between two different independent population. In this case, we're going to use non-parametric methods because uh, the assumption of normality of two population does not depend on this type of test. So we don't know if the distribution are if these two distributions are normally distributed or not, but we can still compare two groups with non-parametric techniques. First of all, I like to combine these two data together. So I'm going to go and cut and paste this here. And then I like to write woman for each value, woman and woman. And I'm going to put man for this group, men. Okay, and let me put a label. I say sample here, and here value and rank. I need to get rid of woman, and I just delete the woman. Now the next step will be to sort this data based on the value. So I'm going to highlight this to data and then go to data, sort, and I like to sort this by colon F by the values smallest to the largest. So the lowest number will be number 1, number 2, rank number 3, rank number 4, 5, and there are 252, so there should be 6.5 for each, 6.5, 6.5, and then I jump to 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.5, another 17.5 because these two are the same number, and then 19, 20, 21, 22.5, another 22.5, and 24. So I have the ranks for each data group. Now I can go and fill my data set. The level of significance 0.01 and sample size 12 for population sample 1, 12, and the other also 12, so I put 12 for both. And now sum of rank. So within men, I'm looking for the total of men rank. So what I did here, I just write a formula, sum if this data E2, E25, if this is men, then take the sum, the rank G2, G25, and then hit OK. So 115.5, or you can do the same thing. Now you can just highlight the data again. Now this time sort the data by sample. Sort the data by sample. So all the men's in one group. Then you can take the total of the rank. Total of the rank. So I go back here, home, auto sum for total of the rank for men. So this is our data. Now if I click, okay, you see 115.5, or you can write a formula, sum if this column E2 to E25, if this is men, so take the total of their rank G2, G25. Or if you are having problem writing this formula, you can just go and sort the data by sample, man and woman, and then take the total for men and take the total for women. And I'm going to take the total for women as well right here, so you can see the alternative way. So highlight the data from G13 to G25, hit enter, so 184.5. If you look at this formula, sum if E2 to E25, this data, E2 to E25, if this is woman, take the sum for their rank, G2 to G25. So, but again, there is an alternative way. If you can sort the data by sample, so you can have all men together, and then you can easily take their sum, the rank, and then you can take the sum of the rank for women. Okay, once we have this, then we need to find out the t statistics and then z-test statistic and compare with the critical value, and then make a decision if their medians are equal or different. Now, in order to do this, so let's have our formula. The formula for this, I'm going to write it down here, paste the formula here. Z-test for, or Z-stat, or for Z-test, T1 minus mu T1 divided by standard deviation of T1. So I'm going to explain all this, what it is. So let's go to our intermediate calculation. So total sample would be B7 plus B10. B7 plus B10, 12 plus 12, so 20. And the next step is T1 test statistics. So T1 equals, you need to compare the sample B7 and B10, B7 and B10, and then you need to take the small one. So if B7 is less than B10, so you take the sum of rank for the small sample. If B10 was the smallest sample, then you take the rank for sum of rank for the smallest sample. In this case, both samples are the same number, and then we go with the first one because B7 less than or equal, so we take the sum for the sum of rank for the first population or the first sample. So T1 test statistics. So T1 equals 115.5 because two sample size are equal, and then our formula says we need to take the small number or equal. If they are equal, so we take the first one. Okay, now then we need to find the T1 mean, and there is a formula for T1 mean. Let me bring the formula for T1 mean, or mu T1. I'm going to post the formula right here. So this says n1 times n plus 1 divided by 2. So T mean, look at here. So since we take B7 as the smallest number, B7 is the smallest number, so we take B14, so total sample, plus 1, B14 plus 1, divided by 2, and times N1, which is the smallest sample size, which is B7 here. If B7 is greater than B10, then we use the small sample, which is B10, which will be V10. So B10 times n plus 1, B14 plus 1. B14 is the total sample size plus 1 divided by 2. In this case, the computer automatically will pick B7 because B7 is equal to B10, so we take B7 part. So this is T mean. So we find the T mean or mu T1, which is 150. Now the standard error, I'm going to bring the standard error as well. Standard error formula. This is the standard error formula. So I want to copy and paste the standard error here. N1 times N2 plus N plus 1 divided by 12. So the standard error, if you look to this formula, so what is N1? First of all, square root SQRT. What is N1? N1 is B7, sample size 1, times sample size 2, which is B10, and times N plus 1, B14 plus 1 divided by 12. So standard error is 17.3205. And then z-test statistic or z-stat would be T1 minus mu T1. You see these two are the same thing. So, and then divided by standard error of T1. Okay, let's go to our z-stat. So you can see, you can follow here B15, which is T1 test statistics. So T1 minus mu T1, which is this part here. So we already find this T1 mean, which is B16. So B15 minus B16 divided by B17. B17 is this denominator, which we find right here, which is B17. So once you find the z-test statistics, then the next step is to find the critical values. And the way we find the critical values is pretty much the same what we did before. Norm.s.inv B4, which is level of significance, divided by 2. The reason because we divide by 2, it is 2 tail. So this is for lower limit, and then upper limit is the same with the different sign. So if the test value is between lower critical and upper critical, that means the medians are different. The medians are similar or the same. There is no difference. So that is H0 accept. Now in this case, as you can see, the number minus 1.99 is between minus 2.5758 and 2.5758. So this is between these two numbers, and then we can say H0 accept, H1 reject, and then once we accept H0, that means there is no difference between the median of these two groups. So do not reject the null hypothesis. You can see this from the p-value. If the p-value is less than 1%, if depending on the level of significance, if this value is less than the significant value, then we say H1 accept. But in this case, you can see this is greater than the level of significance, then we say H0 accept, do not reject null hypothesis, but reject H1.